All right, guys, good morning. Happy time change, right? Hyperbolas are kind of cool little beings. They have a very funny definition. Remember when we did the thing on the board over there for ellipses? That was pretty cool, how we got an ellipse, right, with the piece of string. Yeah, hyperbolas are gonna look like this, almost like two parabolas. They're a little bit different than a parabola in that they approach an asymptote. But this is the fancy definition. It is the sum. Remember how that was, the string stayed the same the whole time? So the sum of the distance from one focal point to the ellipse and back to the other focal point stayed the same at all times, the string length, okay? This is the difference between these. So the difference from, if I pick a point on the hyperbola and I measure to each focal point and I subtract that, it will be a constant. Any other point I pick and I find the distance to each focal point and subtract, that would be a constant. So it's a weird definition. The use they show for this says lightning detection systems use multiple sensors to digitize lightning and then figure out where it came from. Okay, two sensors detect a signal at slightly different times and generate a point on a hyperbola where the distance from each sensor is proportional to the difference in the time of arrival. That makes it possible to transmit the exact location of a lightning strike in real time. I wonder if they use that same technology to track phones and your location and all that kind of stuff. I don't know. The difference in how far you are away from certain cell towers or something. I really don't know. All right, but fancy definition we don't need. I do have some examples here. Does anybody remember what this first one was? Okay, that's a circle. This one, when we divided, was an ellipse, okay? The difference now is going to be that we are going to have a subtract in the middle, and it's going to be a hyperbola. Now, please notice the difference between the blue and the green is only the subtract, okay? It's like we took that blue and we tore it apart and reflected it out. Now, what's the difference between the green and the one I'm going to do next? Yes, the X's and Y's are switched. So what happens is it opens the other direction. Okay, so when the X's were, this X quantity was positive before the minus, right? Then it opened in the X direction as though the axis of symmetry would be, well, what's called the transverse axis, I think, would go through here, and it opens around a horizontal line. When the Y, okay, is over the positive or in front of the minus here, the Y is out front, then it opens up and it opens down. All right. Back here. This says, what is the difference between a parabola and a hyperbola? And I don't remember what's on this slide. It says there are two different sections of the conic. Okay. We talked about that. A parabola versus a hyperbola. The hyperbola issue is that while it gets closer and closer to an asymptote, it does not get infinitely wide, where a parabola will keep getting infinitely wider, okay? I'm going to go with that difference, and then we're just going to keep going because I don't think we have time for all this. All right, so our learning targets are to know how to graph them. You will have to state the center, vertices, foci, and asymptotes. Okay, equations of asymptotes, guys. That's what makes this really fun. All right, you're going to have to be able to complete the square, find the eccentricity, and eventually write the equation. That's not today's lesson, though. All right, so this blue hyperbola is opening up and down. So the transverse axis, they say, is the one that runs through it. The conjugate axis runs the other direction. These are the asymptotes, the red lines, and the center is here. You will notice the foci are inside, just like they would be on a parabola. They're inside the curvature, okay? Now, the transverse axis has a length of 2a. So from this vertex to this vertex is 2a, and then going across the other way, we'd have 2b. Yes, Adriana, sorry, yes, Adriana, I said your name wrong again. All right, you have a reference sheet. Everybody find their reference sheet where it has hyperbolas on it. Is there a little box out front that says something about what the difference between A and B is? Okay, so a squared, do you notice here a squared is under x, and here a squared is under y? Everybody get that? It's not A is bigger than B this time. B can be bigger than A this time, okay? So what it has to do with, A is the one underneath the positive term. So when it's under the X, it opens sideways like this. When it's underneath the Y, it opens up and down like this. It changes everything though when you get down here, like this. Guys, slope is, this is point slope form. Does everybody recognize this as point slope form? Okay. This is the slope, and why is the slope B over A on this one? Does anybody know? The B is underneath the Y, right? And what's the definition slope? Change in Y over change in X. So this one has the B under the Y, so it's B over A. But when they do this one, the slope becomes A over B. Can anybody explain why? Yes, this is still change in Y over change in X. A is underneath the Y, so the slope becomes A over B. All right, the other huge difference, do you remember for an ellipse, the definition of c squared, anybody? It was a squared minus b squared. Guess what? Because this needs to move out and the foci need to be inside the curvature, they are further apart. So c squared is a squared plus b squared, which sounds exactly like Pythagorean theorem, right? But you got to keep it straight in your head that it is different than an ellipse. That's why I'm letting you use the reference sheet. Okay, and you need the c to find the foci, and you will need the c to find the ellipse. What else is true, guys? What do these have to equal? 1. Yeah, very much like an ellipse. What's the only difference between this and ellipse? Besides the graph, in the equation, what's the difference? In the middle, there is a minus. All right. The relationship between A, B, and C is different from a hyperbola than an ellipse. It is added, okay? It is the same, though, in that you're going to draw the points as though you were going to draw an ellipse, but you're going to draw a rectangle. This is called the auxiliary rectangle, and you draw it so that you can accurately put in these diagonals of the rectangle, and those are the asymptotes. Okay, that was a lot of vocabulary. You're going to go, just like you would go out when you had an ellipse, you would go like A each direction and B each direction from the center. We're going to do the same thing, but instead of drawing an ellipse, we're going to draw a rectangle through those points. And then we're going to draw in the diagonals accurately. And those diagonals are going to be the asymptotes. All right. So I don't know what this is. I made another one of these today, I think, that I didn't need to make. Okay, so this is a basic ellipse. If I divided everything by 4, anybody tell me what's going to change when I go to this one? Any ideas? The y squared is the positive, so it's going to open which way? Yeah, it's going to open. Now this one is also very flat. Okay. Now the difference between these two, what do you notice between these two? Yeah, one has a plus in here. This one is an ellipse. But where has the center moved? Anybody tell me? 4 to the right and down 2, okay? So 4 to the right, down 2, move the center. And then this one is actually still an ellipse, unless I were to change this to a minus in here, and then it would become a hyperbola, okay? So that's the difference in those. All right, you don't even have this one, so I'm going to go real quick. This is y first, so it says in the y direction, I go from the origin because the center is at the origin for this one. I go 3 in the y direction, that would be here and here. In the x direction, anybody guessing? I go 5, so A was 3 and B was 5. I go 5 this way and 5 this way. Then what you do is you draw a rectangle. And you accurately draw in those diagonals that go through the center and the corners. Now, mine's horrible. When you get to that point, then you can find the vertices. Are the vertices the top and bottom or left and right of this box? Anybody know? Yeah, because it started with a Y. This is a vertice. So the vertices were at over 0, up 3, plus or minus. Up and down 3, and it actually goes through that point, and it's the only place it touches the box or the auxiliary rectangle. There are no, so to speak, co-vertices here, and it shouldn't be touching the asymptote, by the way. It should be getting closer and closer, but not touching. But I do have to find the foci. So if a squared is 9 and b squared is 25, c squared is 9 plus 25, or 34. So c is plus or minus the square root of 34, which would be almost 6. And it's inside of the curve, so it's on this y-axis. So it's going to be at 0 plus or minus the square root of 34, which is almost 6 up here and almost 6 down here. Seem okay? The other thing you have to do, the part that's going to be a little tricky, is you have to find the equation of those asymptotes. It's point slope form. But guess what point those asymptotes went through? Yeah, they went through the center, right? Wherever that center is. So this one, it's just 0, 0. And the slope is change in y over change in x, so it's going to be 3 and 5, yes. And it's going to be plus or minus the change in y over the change in x, which is the 3 over 5. I went up 3 and over 5. Does that make sense when you look at the picture? All right, those are the asymptotes. Let's try the one that you do have real quick. It says y over 16 minus y squared over 16 minus x squared over 4 equals 1. So where's the center, guys? So we have 0, 0 is the center. And how much does it go in the y direction? So we go up to 4 and down to -4. And how much does it go in the x direction? Okay, everybody get where he's getting those numbers? Underneath the x, that's b squared. So b squared is 4, so b is 2, goes 2 either way. All right, so then we can make our rectangle, which with this goofy graph paper is really tiny. Then we have to put in accurately the asymptotes, and they go through the corners of the rectangle and through the center, but they are not actually part of the graph. We haven't drawn, well, I shouldn't say we haven't drawn anything. We've made 2 dots that are actually part of the graph. Are they the 2 dots at the top and bottom or left and right? Okay, because the y squared was the positive, it's going to open up and down. So this is a vertice up here. It says you're going to put in h, which was 0, comma k, which was 0, plus or minus, 4. I shouldn't have had a comma there. So it's across 0 and up or down 4. And that was because it was square root of 16. Those are the vertices. So you can draw this now. It should be 2 narrow curves having concave up and concave down. It should not be touching the asymptotes. Mine aren't very good. All right, 2 more things you have to find are the foci and the asymptotes, equations of the asymptotes. All right, to find c, what do we do with a squared and b squared again? Add them. So these are already squared. So we have 16 plus 4. So c is the square root of 20, or 2 square roots of 5. Did I do that right, guys? Plus or minus, try that again. Plus or minus 2 square roots of 5. So if you're graphing, they're going to be on which axis? The y. So it would be h is 0, k is 0, plus or minus c, which is 2 square roots of 5, or the square root of 20, which would be somewhere between 4 and 5. They're up just inside of here. Anybody know why it's just inside of there? Do you remember what happened when the foci was close to the vertex of a parabola? It was very narrow. This one is very narrow, right? Okay. Asymptotes. The center is what? So they're just going through 0, 0. So h and k are just 0 and 0. The slope is plus or minus. Now be careful. This was squared. The change in y over the change in x. Remember that this was square rooted to 4 and this was square rooted to 2. We went up 4 and over 2 for our little box. What does that reduce to? 2. So we have y minus 0 equals plus or minus 2 times x minus 0, or just y equals plus or minus 2x for this one, because it goes through 0, 0. All right, see how far you can get on this one. You have this one on 7B. What's A? Anybody tell me A or B or C? So here B is bigger, but it's going to open which way? It's going to open this way. All right, C is the square root of 25 plus 36, or what is that, 61? Which would make it almost 8. Like 7 plus or minus 7.8. All right, so tell me where the vertices are. Be careful. I'm going out 5, but on which axis? Yes, those are the vertices. I went 5 left, 5 right and 5 left. Now, I'm going to go up and down how much? 6, but those don't actually have a name. They're just the edge of the box. What's the box called again? Yeah, auxiliary rectangle. I didn't know that until I started teaching this. We draw a rectangle. Instead of an ellipse, we draw this rectangle. Then we go ahead and put the asymptotes in, which are the diagonals of the rectangle, and they should go through the center. And this particular hyperbola opens left and right. So over here. And it's pretty flat, according to my picture anyway. So it seems like the foci are going to be a little ways inside. Does that make sense? A little further inside. All right, all I have so far is the vertices and a beautiful graph. I need also the equations of the foci and the asymptotes. Anybody help me with either one of those? Okay, that would be 0 plus or minus 7.81 or square root of 61, comma 0. So plus or minus the square root of 61, 0 are the foci. We can graph them at almost 8, right? And negative 8. And they seem pretty far inside comparatively, right? And the equations of the asymptotes are y minus k plus or minus, what goes here? Yes, this one is opening sideways, so it's b over a. I just look what's underneath y and what's underneath x, okay? Make sure you square root those, so it's going to be 6 over 5, and then x minus 0, so y equals plus or minus 6/5 x. Does that work for the box? Did we go up 6 and over 5 when we drew our box? Our auxiliary rectangle? Yes, we did. And you could have left it like this, guys. You can leave the equations in that form, okay? For the asymptotes, all of them can be left in that form. You do not have to mess with it. All right, what are they trying to do to us now? Yes, we have to slide this left, right, up, down. But be real careful. What's h? H is not 3. Okay, this is y minus k squared over a squared, because it's positive, and this is x minus h squared over b squared. So h is what again? Negative 2, k is positive 3, a is 5, b is, anybody? 3. And then c is the square root of, these are a squared and b squared, so it's 25 plus 9 or 34. All right, so tell me something. Where's the center, anybody? Yes, it's hk in that order. So negative 2 and up 3 is the center of the box. Now from the center of the box, how much do I go to the left or right? I go 3 because that's underneath the x. 2, 3. 2, 3. Okay. How much do I go up and down? In the y direction, underneath the y here was 25, so I go up 5. 1, 2, 3, 4, 5. Okay, which way is this one opening? Why is it opening up and down? Okay, the positive is the Y here. So it is going to open up and down. I have to accurately draw in those asymptotes. They have to go through the corners of the box and the center. They don't necessarily go through 0, 0. Okay, I feel like they've all gone up and down, but anyway, this one, the last one was side to side? Okay. This one opens up and down. It's not supposed to touch the asymptotes. I didn't do a very good job of drawing it. Okay, so we need the vertices and the foci. The vertices were, what's the formula for vertices when it's opening up and down? Let me see. H comma K plus or minus A, is that right? So we would have -2 comma 3 plus or minus 5. Can you give me those actual ordered pairs, guys? -2, 8, and -2, -2. Everybody good? You need to actually tell me the ordered pairs. All right, then the foci, the equation is H comma K plus or minus C, I'm guessing. Did I get that right? So that would be -2 comma 3 plus or minus the square root of 34. Which you could leave, but can you give me a couple decimals so we know we got them in the right spot? 3 plus the square root of 34 is 8.8. And 3 minus the square root of 34 was what? Okay, so just 0.8 inside of here and 0.8 down this way is where we wound up, but that's okay as long as it's inside, right? If it was inside the rectangle, then we'd know we did something wrong. These were where the foci were graphed closely inside. All right, what am I missing? Okay, so the equation of asymptotes is y minus k equals plus or minus. For this one, it should be A over B. All right, what's K? A over B would be, does that match the box who went up 5 and over 3? And then X minus -2 became X plus 2. And you can leave it just like that. Don't mess with it, okay? Any questions? So how far can you get on your own on this one? Give you a 30-second head start. Adriana, what do you have?
I have AS1, AS6, and CS52.
That sounds right to me. Okay. Square root of 52. Is that just 4 times 13, so 2 square roots of 13. You could just leave it square root of 52, really, I'm not that picky, but anybody have the center? Yeah, h was 1 and k was negative 2. So 1, negative 2. How much did you go up and down from 1, negative 2? 2, 4, 6. 2, 4, 6. How much did you go left and right from negative 2? 2, 4. Anybody have the vertices then? Good job. All right. Now before I try to draw this, I need to draw the rectangle. And the asymptotes, which have to go through the corners of the rectangle. And then which way was this one opening? So the vertices were lining up horizontally. Right. What about the foci, guys? What's the formula there? H plus or minus C, comma K, is that right? Did I read it right, guys? For when it opens sideways, is it H plus or minus C, comma K? Everybody find it? All right, did anybody do the decimals? So it's pretty far inside, which makes sense because they're pretty wide open, right? All right, asymptotes, y minus, what is the one point it goes through? The center, right? So it's y minus this y value of negative 2, so it becomes plus 2, equals plus or minus the slope. We changed in the y direction and the x direction, says b over a. So 6 over 4, which reduces to 3/2. And then it's x minus h, which was 1. And you can leave it just like that. Any questions? Feel pretty comfortable with the graphing and finding everything? All right, so we are going to have to write equations of these, but we're going to wait till tomorrow, okay? Today, what we're going to practice is completing the square. It says when converting from general form to standard form, always remember that the difference of the two algebraic terms must be equal to 1. So we have to still make it equal to 1. If it has a plus in the middle, it is either an ellipse or a circle. If it has a minus in the middle of two squared terms, it's going to be a hyperbola. What is a parabola? Only one variable is squared for it to be a parabola. All right, so number 16. What we do is we separate the x's and y's. Please, guys, pay attention on this. Completing this square. What am I moving to the other side? The constant, so I'm subtracting it to the other side, it's a negative 4. So, anybody tell me the equation? X minus 2, because it's half of negative 4. Squared, when I square that, I would add 4. Plus, there's no coefficient in front. So this is half of this, which would be plus 3. Squared would make it a 9. Make sure both of those quantities are squared. And then if we add to both sides, okay, oh, good. We get 9. What is that? It is a circle. If we made it equal to, and it wouldn't be wrong, if you decided, oh, I'm supposed to divide everything by 9, so that this side became a 1, then it seems like an ellipse, but what's it going in each direction? 3, the same amount, so it would be a circle, okay? All right, number 17. Anybody know what that one's going to be ahead of time? Why are you thinking ellipse? Yeah, it's stretched in an X and Y, 2 different dimensions, right? 9 and 4. But nothing is negative. If it had a minus somewhere, then it would be possibly a hyperbola. All right. So we're going to move the X squareds together and the Y squareds together, and the constant to the other side. But then what do we have to do to the X squareds? The coefficient to be able to square has to be positive 1. What can I take out of both of these? A 9. Then I will have a positive 1x squared plus 6x plus blank. These two back here, I need to take a positive 4 out, so I have y squared plus 2y plus blank. And then I have a negative 49 plus 2 blanks. Completing the square is what really, some students just struggle, and then it's a mess from here on out. All right, so we keep the 9 in front. This parenthesis, instead of x squared plus 6x plus blank, becomes x minus 3. Is that right? No, it's not minus, right? X plus 3. When we square it, we get 9, but what did we add to that side then? 9 nines, or 81. Then for the y, there was a 4 out front, but half of this is plus 1. Squared is 1, but I really added 4 times 1, or 4 to the other side. Negative 49 plus 81 plus 4. I'm guessing 25. Is it 35? 25? $36? Yep. I'm not a good guesser. Did everybody get 36 over there? Now what? Divide everything by 36 and nice things happen. We have x plus 3, quantity squared. 9 goes into 36 4 times. 4 goes into 36 9 times, with a y plus 1 squared up here, equals 1. Ellipse, hyperbola, parabola. I don't know what just happened. I lost my pen. It's an ellipse because of the plus in the middle. Everybody okay? All right, how far did you get on 18? (25) x squared minus Anybody get a 25 on the right side? So when we divide by 25, I have x minus 1 squared, oops, x minus 6. I don't know where I got a 1. Oh, it's over 1. There we go. Y plus 4 squared over 25 equals 1. What is this? It is still an ellipse because it has a plus in the middle. It would be very long and skinny going which way? Yes. Okay. It would be over here centered at 6, 4. Going left and right only 1, but up and down 5. So it would be very long and skinny that way. Smooshed. Okay. Number 19. Does anybody see what the problem is going to be here? Okay, I have 16 x squared. If I take a 16 out of 96, I get 6x plus blank. Now, I have to factor something out of the y's. What do I have to factor out, guys? A -1. Because the y squared coefficient has to be +1. So I'm taking a -1 out. So this just becomes a y squared, but this is where everybody messes up. When I take a -1 out of plus 8y, I have what? Minus 8y. Okay, I probably should have said 16x squared plus 96x. Then back here was a minus y squared plus 8y. I'm taking out a -1. Over here I have a -112. I always hate this because half the class is lost and not paying attention. The other half the class is really good at these. Right here, I take half and I get what? X plus 3, not minus 3. Squared is 9, but what am I adding to the other side? 16 times 9, yes. Then I have minus 1. What goes back here? It's not plus 4. Minus 4, which is a 16 in the parenthesis, but what am I adding to the other side then? A -16. Now, I think this one's going to really mess you up. -112, maybe not, plus 16 times 9, minus 16 is positive 16. Sometimes you get a negative on the right side. If you get a negative on the right side and you have to divide by a negative, you're going to have to rearrange the order of everything. So we have x plus 3 quantity squared over 1 minus y minus 4 quantity squared over 16 equals 1. Is this a hyperbola or an ellipse? and it opens left and right. The auxiliary rectangle would be left 3 and up 4, and it would go 1 to the left and right and be very long and skinny this way, and then we'd have a parabola opening this way. All right, here's the assignment. Grab some graph paper if you want.